integrand is handable in both directions, which means in some situations it will be hard for me to integrate dx dy. It will be better for me to integrate dy dx. And here is the choice will come. And also, the entrance is one function and the exit is one function. And I will show you this down the road. So, before going further, I will need to identify this function, the function of this line or this border is simply y equal to 0. And the function for this border is simply x equal to 0. I will need the relation connecting 0, 2, and 1, and 0, which is the equation of a straight line by knowing 2 points on this straight line, which is y minus y1 over x minus x1 equal to y2 minus y1 over x2 minus x1. That is going to be really very simple because all I have to do now is to make direct substitution. But just put or determine which is going to be b1 and b2. I will choose this is for b1 and that point is for b2. And I will start substituting directly. So it's a y minus 0 over x minus 1. And it's going to equal to 2 minus 0 over 0 minus 1. And that will leave me with the relation of this straight line, which is y equal negative 2x minus 1. I believe, let's go dy dx. So as I told you, it will make no difference. But since I have y as a function in x for the exit, so I will consider dy. Let's start with that. بص يا ابراهيم، انا حددت الريجن صح؟ ابدا بقى اختار انت مليني. انا همشي في الدايركشن بتاع الدي واي. الانترنس اسمه ايه؟ مين الفانكشن اللي will allow you to enter your region starting from y equal to 0 from the boundary over there from the x-axis. So now I want to form or to get my double integration for this region. The integrand will be the same, x squared y. I'm integrating in the direction of dy first. So I will look to the gate. Where is the gate? This line. And the equation of this line is simply y equal to 0. I will be inside the region. I'm here inside the region. Here we go. I'm inside the region. Where is the gate that will let me go out my region or the boundary? Y equal to negative 2x minus 1. That's the gate. So if I'm entering from this side, what's the gate? Or where is the exit? The exit will be this boundary. So I will integrate up to y equal 2x, or I'm sorry, negative of a 2 of an x minus 1. I will integrate from y0 up to this point. And the region on the other direction, on the x direction, is going to start from x equal to 0, and the end of my region will be at x equal to 1. So actually, for the second integration, it will be from 0 up to 1. Now I have the boundaries. That's the point that should be addressed and dealt with. So first of all, that's the first direction. That's the entrance. That's the exit. I should have their equations. Y equal to 0, y equal negative 2x minus 1. And for the second direction, it will be x from 0 up to 1. Here we go. That's my integration. So now I will integrate with respect to dy. Integrating with respect to dy. So it's going to be x squared times y to the power of 2 over 2. Here we go. Then I will replace each y. First, with the value of the upper limit of the integration limit, negative 2x plus 2, minus replacing y by 0. This is what all I have to do. Okay, Ibrahim? Here we go. Replacing y by negative 2x plus 2 and then multiplying the x squared, this is going to be the result. Minus replacing the y equal to 0 will make all of this disappear. So that's the integrand now, or that's the value of the inner integration. I will take it, insert it once more, and start integrating in the direction of x. Finalizing everything, this is going to be 2x to the power of 5 over 5, negative 4x power 4 over 4, then 2x power 3 over 3. That's the relation that I will have. Then I will start making the substitutions, replacing every x by 1, minus replacing every x by 0, and I will get the value which is 1 over 15, as you can see. So actually, the double integration, it's not that hard. It's really handleable and manageable. Now for the mixed regions, I want to skip this because you have it on your PDF. You can go through it as many times as you want. Now if I want to integrate on a region like this, what are the steps that I will have? First of all, I will have to determine my boundaries. Number 1, the equation of the boundaries. Number 2, the intersection, if exists, between these boundaries should be identified. Then start to decide which direction are you going to. So now, for example, this is stand for y equal to x squared, and that's for y equal to root of x. I want to integrate through this region, the region bounded by these two boundaries. If I went first in the y direction, so the entrance for me is going to be y equal to x squared. I'm inside and the exit will be y equal root of x. Then I will finish them by the direction of the x. Starting this region between x equal to 0 and x equal to 1, I will find the value of the integration that I'm aiming to have. Okay? Once more, let's see it on this problem. This is a very good problem, by the way. Very good. Okay, let's go through it step by step. A question, please. Any one of you can integrate this function as it is? Can you integrate this function as it is?
Yes.
Nope.
You can.
Because, no you can't.
There's no derivative.
Because simply, if you have e to the power of an f of x with respect to the x, for example, you should have the derivative of the power beside your function before integrating. And simply, I don't have here 4x cubed. So I can't do it in the x direction.
Why don't we switch to the dy and the x?
This is what we are going to do exactly. This is why it will make a difference to go in some problems dx dy or dy before
Then we
dx.
just take the y.
Yes. So now I will replace the order of integration. And instead of doing dx dy, I will do dy first. But in order to do this, you will have to determine your region. So let's determine our region. Okay, to determine our region, we need to be actually skillful about how to, first of all, analyze what's given. I'm integrating first with respect to dx. So I will start from x, here we go, equal the cubic root of y. And that will end at x equal to 2. Am I right?
Right.
Okay, which means that y equal to x to the power of 3 if I'm changing and getting y. And also, Ibrahim, in the direction of dy, I'm starting from y equal to 0 till I reach y equal to 8. Let's mimic this on the graph. So the function is y equal to x cubed. That's the function which is y x equal x cubed, and it goes from here. And he's telling me that the region in the direction of the dx will start from here first, and it will end at x equal to 2. So that's the dx direction. Starts from x equal root cube of y, that's y equal x to the power of 3, and it will end at x equal to 2, that's the boundary of my region. So it will happen at x equal to 2. And in the dy direction, your region is in between 0 and 8. It makes complete sense, because if you inserted x here be 2, you will find y equal to 8. Now I'm replacing the order of integration. Let's do it, Ibrahim, together. I will go first in the direction of
dy.
So the entrance will be y equal to 0. That's the entrance for my region. and the exit is going to be y equal to x cubed. Then I will finish them with dx. The beginning of my region at x equal to 0, and the end will be at x equal to 2. Let's do it. So I will start integrating. Here we go. In the direction of dy, I will start from y equal to 0 till y equal to x cubed. For the function, which is e to the power of x to the power 4, in the direction of dy. Then I will finish everything with the direction of dx. So this region, that's the region that we are interested in, starts in the x direction from x equal to 0 up to x equal to 2. So from x equal to 0 to x equal to 2. Now I can integrate Ibrahim. The first part can't be integrated because simply you don't have x to the power of 3. But now, once you replace the order of integration, it is handable. I will integrate first with respect to dy. So it's going to be a y times e to the power of x to the power of 4, and it is running from 0 up to x to the power of 3. But remember, that's substitution for y only. Once you finish this, start integrating in the direction of dx from 0 to 2. So, just making the substitution will leave you with x cubed times e to the power of x to the power of 4. Here we go. Minus inserting y equal to 0, so it will disappear. Now I will start to integrate with respect to dx from 0 to 2. I will multiply by 4 and divide by 4. Do you know why? Do you know why I multiplied by 4 and divided by 4? Because simply, I will have to have the derivative of the power already exist. Now, I'm ready to integrate and finalize it. So it's going to be e to the power of x power 4 over 4. And I will make the substitution from 0 to 2 and finalize everything. So, once more, mark that. If we want to integrate, the only way is to invert the integration direction. Doesn't matter the integration direction. Okay, here we go. Remark, we cannot integrate the integrand simply because the derivative of the power doesn't exist. That's the remark that we said. So, I will have to make a change of order of integration. In order to do so, these are the main steps. I wrote them for you. First of all, get all boundaries and identify them. This is exactly what we did, Ibrahim. Getting all the boundaries all together and identifying them. Number 2, it is better if you draw your region, because once you draw your region and mimic the dx dy direction first to be sure that's the integrated area that you aim for, then determine the boundaries in the other direction, then finalize your integration. And that's exactly what we did. From x to 2, xy to the power of 1/3, which leads to y equal x cubed, running from y equal to 0 up to y equal to 8. So this is actually y equal to x cubed, and starts from x equal to 2, and that's y equal to 8. That's the region that we are interested in. I will go for the direction dy first, then I will go for the direction of dx2. Okay, very simple. Now I will start integrating ex to the power of 4 in the direction of dy, which is going to be y times e to the power of x to the power of 4. Replacing every y by x cubed minus replacing every y by 0, I will have this guy. So it's going to come up to x cubed times e to the x power of 4. And I will start now making the integration with respect to the x. This is why I multiplied by 4 and divided by 4. Now it is integrable and finalizing everything by your substitution. As you can see, it's a very simple problem, okay, but it takes a lot of work and dedication. General probabilities of characteristics and the characteristics of multiple integral in the multivariable functions. Of course, we are dealing with multivariable functions because we are integrating in x and y direction. Okay, double integrals have wide-ranging applications in mathematics, physics, engineering, and in other sciences. For example, the area of a region is simply by integrating with no function. So if you integrate with respect to your region, just only the boundaries, you will get your area. If you multiply by a function f of xy, like what we did here in the previous examples, I will get the volume under the surface over the region R. If you need to get the center of mass, all I have to do is just to substitute in this equation. I will get x bar and y bar. This is a very important application. If I want to get the mass, it's going to be like this. If I want to have the moment of inertia, measure rotational resistance, it's going to be integrating for y square root of xy, which is the A. If you want to use it in probability, then you will be able to evaluate the probability of a region by just direct substitution in the slope. This is the mass, the heat, and the mass transfer, temperature times rho of xy, and integrating through your double integration area. And this is for the electric charge, just integrating sigma of the charge intensity, and you will have your flux. Okay. This is additivity. Of course, double integration, it's an integration in general, so it proves the additivity property. The linearity property also is applied for linear double integration, and we really saw all of this. Calculate the double integration for root of x dA over the indicated region. I will say this example, and it is enough for today. But I need you to look at it, Ibrahim. I want to integrate root of x for the region given by the following region. Look to the region. It is y equal to x, and that's x equal to e to the power of 1. So this is mainly the region that we are interested in. Now I will have to think how to target this area. Should I go dy dx or dx dy? If I went in the direction of the dy first, I will find that the entrance will be two functions. Before one, this is the entrance for my region. And above one, that's going to be the gate for my region. So now I will have to divide the double integration into how many integrals? Into two parts. Because the entrance is just formed of two functions.
But I can't divide it into two integrations. Like
Yes, you can. But why to exert all this effort?
Yeah.
Why?
The y first.
If you do the x first,
The entrance is y equal x.
the entrance is going to be just only this guy, and that's the exit. So now I will start to understand how to choose my side of integration. Well, we can integrate in both directions, it's okay. But I would prefer integrating dx dy because I will have just only one integration. It will be very smooth. So all I have to do, doing the first integration with respect to dx, the second integration will be with respect to dy. So all I have to do, root of x dx, I will integrate from x equal to y up to x equal to e to the power of 1. Then I will finish everything with the y direction, starting from y equal to 0 up to y equal to 1. So that's the integration in dy. So integrating rho x is going to be x to the power of 3 over 2 over 3 over 2. Then making the substitution of x e power y minus y. Then I will finish everything by integrating now this guy with respect to dy, and then making the substitution and simplify it. It's really very simple. I will say it's enough for today, and I will start tomorrow with the transformation of the plan if I needed to make a transformation or a polar coordinate substitution in order to simplify our lives. Thank you very much for watching, and I hope you have finished this with me. Thank you, and with my best regards for you as always. Thank you very much. Thank you. Bye.
كده صح؟ فتحي بقى دكتور عمر ما بعملهاش كتير خالص كده عفوا